A very good afternoon, friends. Last lecture we deal with the various work holding devices. For that particular important characteristics, next for this lecture we can deal with the remaining work holding devices and its aspects. Here the case is hollow square tube. This is the another case where in this particular diagram you can see this is the boring tool, this is the tool holder, arbor, and entire this is the head. On this table we have to drill on this particular product or this particular job. When we keep this particular job on this table, there is a chances that destruction to the table or to the cutter while drilling this particular slot. To avoid this, we can take slightly changes, we can make slightly changes in the clamping device or work holding devices, where this particular part 1 and part 2 is inserted below this particular job and clamp it. So boring it is a time consuming, and try to use the standard hole size to avoid using the boring head. So clamp near work. What are the important aspects for this particular hollow square tube? So first of all, you clamp near work. Here the clamping action happens as near the cutting action is inconvenient, or cutting action is convenient. Look at this, you can clamp this particular near to the hole, so then it can be convenient and the maximum efficiency of the clamp is assured for this particular case. So where is that tool going? These machine slots in the workpiece required careful cutter to clamp, because look at this, these are the slots in the particular workpiece. So you have to be take the careful action. So to avoid the collision where cutting action is underway, we can work is held above the table. Look at this, work is this particular workpiece is held above the table to allow the cutter clearance. This is the cutter clearance. So avoid the cutting into the table of the machine. So another, this is a technique of work holding devices. Next is a large radius slot. You can see this is the indexable table. This is the degrees are marked over here. So the milling of a slot on the thin and small work creates difficulty in placing the clamps. Care must be used to avoid tool to clamp contact during the cutting is that rotatable. This tool allows the work to move in a polar directions, in any direction, angle, clockwise or anti-clockwise, polar direction. Setup time for the tool can be long, complicated and difficult depending upon the required precision. Good design for manufacturability should minimize the use of this particular tool. So what under the tool? A thin aluminum plate has been used here, a sacrificial role to avoid damage to the machine and tooling. The cutter is allowed to lightly cut the underlying plate but not the rotary table. Look at this. This particular plate has been introduced to avoid the tool damage. Next is drill press work. Look at this. There is a twist action always be there when you drill any job. Look at this. This is the clockwise rotation of the tool. Hence it make the twisting movement. Look at in this direction, clockwise direction. If this is moving in anti-clockwise direction, this will be in opposite direction. So second, use always second voice. Look at this second voice. This is the here and here. These are the second voice. This is the first voice. This is the second voice to avoid the twisting. So use the second voice to keep the work from rotating axially in the main voice. This aspects is this setup is okay, as large axial rotation force not expected if the drill is accurately centered. In this setup, the operator is being used to resist the torque generated by the revolving cutter. This particular revolving cutter, it generates the torque. So operator restrict this particular torque. If the drill were to be bind through operator would be struck and injured by the revolving work pieces, so it will be difficult or it will be dangerous. This is an unsafe practice. Use a fixed object like column or the pedestal bearing. Look at this column or pedestal bearing, any of them. It will resist the torque and hence safe for the worker. Next is assembly clamping. assembly is made by coming together different parts. So clamping of the assembly, entire assembly for any process after the assembly is quite difficult for work holding. If necessary, entire assembly can be clamped to a milling table to do certain process under in order to finish the assembly, although not ideal. These actions are performed in certain cases when it may be very difficult and are expensive to dismantle the assembly. Care must be taken to protect the assembly from cutting chips and flutes. Such cases, you must be carefully fix the assembly like this using different work holding devices. Next is drill chuck clamping. You can see clearly the difference of three jaw. This is the three jaw chuck. You can clearly see the difference. In the first case, it will be in either side. Tool is going in the either side, but in the second case, it is exactly at the center. So in the first case, this is incorrect, and second case, this is correct. The first image is incorrect. Note how the center drill is off center. Here, this case off center. This will cause the tool to break or damage your workpiece. It will damage your workpiece. So a second image must be prepared for the clamping. Next is three jaw chuck clamping. Look at this, clearly difference. In the this is also clamping, this is also clamping, but you can notice the tapered section of the part shown. Rather than clamping on the tapered section, it should be desirable to clamp on the straight portion immediately before the taper. Look at this. If you clamp on the taper section, it will be a bent or it will be a moved from this center of axis. But when you clamp this three jaw chuck on the straight portion, it be firmly clamped and it will be centered. So care must be taken where the parts having large overhang. If the large side cutting forces are present, a lever center should be used depending upon the operation. So this is the exact way of three jaw clamping. This is the four jaw chuck clamping. You can see over here. And this is the important point. This is the important point. Notice the gap. This is the gap. Look at this gap. You can from the front view cannot observe the gap. But in case of when we see from the top, this top, you can easily find out the gap. So a four jaw chuck are used to secure the non-circular workpieces in the lathe. For the non-circular workpieces, this four jaw chuck is widely used. Often difficult and it is a time consuming to adjust the work at the center. So work must be secured with their back face parallel to the face of the chuck. This is the back face. So this is the back face which is hold parallel to the chuck. Notice how the first set of images, the workpiece is not properly secured. This is workpiece is not properly secured. But in the second case, workpiece is properly situated where the gap, look at this gap, is near about 0. So this is the best way of holding the job in a four jaw chuck lathe clamping. So thank you very much. These are the different last two lectures. We can see the different work holding devices. As per mentioned different cases, you go through the clamping. Thank you very much.